So this question here, we have a graph, so we start right off with our Oizerga. The origin is here at 0, 0. We found that. Our y-axis is the force. X-axis is time. The intercept, yes, we have a y-intercept of 2.0, so that means at time 0 there was a force. There is also an x-intercept that at about 1.9 seconds, f equals 0. So we can see the force decreases from 2 to 0. We can read force in time. The slope, or the gradient, is delta f over delta t, which is the rate of change in force. And the area is the force times the change in time, which is the impulse. And so we know J equals delta P equals M delta V equals F delta T, our four-way equivalents. So now let's see what we have. Student experiment is pulled by a variable applied force during a 2-second interval. So we have this cart being pulled. There is a force that varies. The delta t is 2 seconds. In trial 1, student exerts a force on a cart of mass m. So mass equals m, and there is a force. In trial 2, it exerts the force, and so that means the force is the same. So it's the same force, and the mass in this case is 3 times the mass. So immediately what we should be expecting here is that if all of these are for 2 seconds, we should expect that the 3-second mass will have it'll have a lower acceleration, it'll have a lower final velocity. Same force, bigger mass. And trial 3, it has a mass of 5m and the same force. So which one will experience the greatest change in momentum from 2 to 0 seconds? So let's take a look at the change in momentum formulas we have. Change in momentum is F delta T. And the definition of the net force is the rate of change of momentum, delta P over delta T. So what we're looking for is what happens to delta P. Well, we know in all these cases it's from 0 to 2 seconds. So we know that's the same. And the net force, we are told in all 3 cases, is the same. Therefore, the change in momentum must be the same. So it's not in trial 1, not in trial 2, not in trial 3. It's equal for all 3 trials, and that's why.